Video we will discuss about transition storage. Transient storage. So let's first discuss about various storing methods in Ethereum, EVM. So we have storage, the data is stored into the blockchain, and we have memory, the data is cleared once after the function call, right? And we have transition storage where the data is cleared after the transaction. So in order to understand what is meant by transition storage, we will go through an example, right? So we have two contracts, test storage as well as the test transition storage. So we're going to call these two contracts with the help of the callback contract. With the help of we have defined the interface in order to call the val as well as the test function and the variable. So as you all know, in Solidity the variable is also considered as a public function if it is declared with a public modifier, right? So first is I will just a special credit to smart contract programmer who created this contract in order to showcase the use cases of transition storage. So let's first let me deploy the contract, and by the way I will explain it, right? So first we will deploy the test transition storage and test storage, and finally the callback contract. So we have deployed all the three contracts as you can see the bottom of the screen. So we will first test the storage. So copy the address of the test storage contract and paste it into the test function of callback contract. So if I check the value, it's going to be updated to 123. And by the way, if I go into the test storage and check the value, it's again 123 because we are using storage in test storage contract. Okay, it is persisted after the transaction. Okay, now we will move on to test transition storage. We'll copy the address of test transition storage and paste it in the callback contract, test it out. Now the value should be updated to 321. Yes, it has been updated. Guess what? Is it there? Is it still there in test transaction transitive storage? No, it's 0. Means once after the transaction ends, the data is being cleared. Okay, so the main use cases of it is hope you have used this reentrancy guard, right? Reentrancy guard. So this can be a perfect use case for reentrancy guard, like locking the contract, like no other external call should enter into the contract, and again once after the function ends we are unlocking the contract. So for that use case, rather than storing the state of the lock into the blockchain, which causes like 100 gases for store as well as slow, we can move on to this transition storage, which causes very less because no data is stored in the blockchain. Once after the transaction ends, the data is cleared. Hope you got it. Like I will share this code in the description. So if you find any doubt regarding this, like kindly leave a comment. Definitely I will answer all of your comments. So thank you for watching. See you on the next video.